In my book on everything evidence-based in weight loss, How Not to Diet, I had a section entitled Amping AMPK. AMPK is an enzyme that acts as a universal fuel gauge for plants and animals, revving up when it detects a depletion of the universal fuel. The universal energy currency in all of biology is a molecule called adenosine triphosphate, commonly known as ATP. The tri in triphosphate means 3, as in tricycle, or in this case ATP's 3 phosphates, where energy is stored. Plants make ATP with energy from the sun, and animals make it by burning fat, carbohydrates, and protein. The energy is spent by releasing the phosphates, which transforms ATP to AMP, adenosine monophosphate, with mono meaning 1, which then can be juiced up with 2 more phosphates back to ATP, and the cycle continues. In this way, every cell in our bodies and in every living thing is like a little rechargeable battery. AMP molecules are charged up with phosphates to ATP using sunlight or food, and then drained back down to AMP to do the cell's work. This brings us to AMPK, or AMP-activated protein kinase. A kinase is a type of enzyme. What might be the function of an enzyme activated by AMP? Buildup of AMP means the rechargeable battery is running low. It's akin to the fuel gauge in your car reading empty. As the needle creeps towards the E, what do? Add more fuel. But instead of having an extra gas can in your trunk, you may have junk in the trunk, fat stores on your body. So that's what AMPK does. It flips the switch in your body from storing fat to burning fat. That's why AMPK is not only known as the master energy sensor in our body, but the fat controller. No wonder I featured it in How Not to Diet. But it can also control aging, and so also plays a starring role in How Not to Age. To sustain life, each of our cell batteries needs to stay fully charged. This means maintaining a ratio of about 100 ATP for every AMP. So our body needs to perfectly balance cellular activities that consume energy with cellular processes that generate energy. In times of plenty, our cells can plow full steam ahead. However, in lean times, which for animals means not enough food, and for plants means not enough light, darkness is like starvation for plants, AMPK kicks in to reorient the cell into conservation mode and start tapping into our energy stores like burning off body fat. Our cells can also institute a recycling program called autophagy. Autophagy comes from the Greek words auto, meaning self, and phagion, meaning to eat. So autophagy literally means self-eating. It's a housekeeping process by which defective cellular components, like misfolded proteins that have been allowed to wastefully build up in times of surplus, are broken down and scrapped for spare parts. This doubles as both salvage operation and quality control, scavenging raw materials in scarce supply, as well as clearing away some of the buildup of damaged debris that is implicated in the aging process. As one review put it, the janitor is the undercover boss. This is one of the reasons AMPK is increasingly recognized as a pro-longevity factor. AMPK induces autophagy, which cleans house, sweeps away accumulated waste, and effectively institutes a sort of cellular reset. There are 3 main ways longevity researchers establish an aging pathway. Does the factor worsen with age? If you amplify it, does it accelerate aging? And if you dampen it, does it slow aging and thereby extend lifespan? The loss of AMPK activity as we age fits all 3 criteria. Our levels of AMPK drop as we grow older, and it gets harder to activate. When this decline is exacerbated, aging is hastened, at least in the hearts of mice, and when this process is reversed, when AMPK activation is boosted, lifespan is extended in model organisms, as much as 38% in a type of microscopic roundworm known as C. elegans. Up and down the evolutionary tree of life, one of the most reliable ways to extend lifespan may be long-term food restriction, and AMPK activation is thought to be one of the mechanisms for this longevity boost. What was remarkable about the AMPK boosting experiments, though, is that animal lives can be extended even though they were allowed to eat as much as they want. So AMPK activators can effectively fool the body into thinking it's starving, flipping it into protective house cleaning mode without having to suffer the pangs of deprivation. AMPK activators can thereby be considered calorie restriction mimetics, or imitators. No wonder AMPK is considered a druggable target for longevity. But is there a way we can naturally boost AMPK activation to slow aging without starving ourselves? The answer is yes, which we'll explore next.